Hey guys! In this video, we'll show how to bring in a denim jacket, t-shirt, and cargo pants from Marvelous Designer into Unreal Engine using the new uDraper's functionality that we've added in the recent update. This functionality allows us to handle elements such as pockets, flaps, and collars. Previously, when we imported OBJ files, we had no information about the layers of the different parts of a garment. That caused problems with garments that had layered pieces, making them look like they were mixed up when we simulated them in Unreal Engine. You can see in this example where pockets and flaps get mixed up with the parts underneath. With the latest update, we can assign specific layers to the parts on top to get a better result. In short, for this jacket, we need to set the breast pockets to layer 1 and the flaps to layer 2. When we import it, uDraper will read this info and handle the layers accordingly. Let's now take a closer look at the whole process. For the denim raw material, we used an original fabric and also copied it for the pockets, sleeves, and cuffs. This allowed us to have better control over these parts in the Unreal Editor. We can also set the skin offset for our avatar to either 0.5 mm or 1 mm to make sure the garment fits snugly. To make the fabric more rigid, we can set the particle distance for all pieces to 20 mm. And just a quick note, make sure that the remesh option is unchecked. We can choose between a triangle or quads mesh style, but we want to avoid using the remesh option because it adds extra small triangles that may cause issues. To keep the jacket from opening too much, we can add a couple of small pieces here and make them transparent in Unreal Engine, so they won't be visible. One piece goes here and another one goes here. Let's run the simulation now and make sure everything looks good. We want the breast pockets to stay on top of the jacket, so we'll assign them a higher layer number of 1. The flaps will have a layer number of 2 since they should be on top of the pockets. The collar should also stay on top of the shoulders, so we'll set its layer to 1 too. To adjust the folding line, we'll select it and set the folding angle to 90 degrees. The adjustable straps should be on layer 1. And we'll sew them in place like this. Let's run the simulation one more time to prepare the mesh for exporting. Remember, if we want the top stitches to be visible, we need to bake the textures. Check the UV editor to make sure everything fits in the first quadrant without any overlapping. When we bake the textures, make sure the top stitch types are set to texture. If you want better visibility, you can make the top stitches thicker and longer. Let's jump into our Unreal Editor where we've already got a metahuman character set up with the Draper components. We'll select the top garment, click the MD button, and choose where to save our exported file. We'll save it under the denim jacket name, and in the Import Garment dialog, we'll select textures to be compressed. This will help the textures load faster by storing them in DDS format. Next up, we'll bake our maps and set the texture size to 4096. After that, we'll hit the import button and let the process run automatically. Once it's done, we might need to adjust the garment's position and our materials. Let's start by working on those transparent pieces. We'll head to the Alpha section, get rid of the Alpha map, and set the opacity to 0. Up next is the trims material. We don't need the alpha channel, but we want to use the base texture. And we want to add some thickness. Let's make it, for example, 3 mm and apply a 2 mm bias. This should make these parts stand out more on top of the main material. We can also make the normal map stronger by setting it to less than 1. Just remember to save those material settings. Now, let's move on to the pockets material and apply the same thickness and normal strength of 0.5. Don't forget to save that too. We'll do the same thing for the cuffs. Then sleeves. And finally for the main material. All done. Let's give it a go and start the simulation to see the jacket settle into its new position on the avatar. We can stop the simulation and go back to our garment settings. We can get rid of that transform and turn on the wrapping option. The jacket will be right where we saved it. Moving on to another scene where we've already got some buttons ready. We've named all the Draper attachment components as button 1, 2, and so on, and the button static meshes as BTN. We've also added a seam component just to keep everything together. When positioning an attachment, make sure the green arrow is pointing perpendicular to the material. Once you've got the first attachment set up, you can just duplicate it and move it around as needed. You might notice that the buttons disappear when you move away from the character. That's because of the fabric's world position offset, but no worries. When the simulation starts, the attachments will have the same offset as the material they're attached to. Let's hit play and use the mouse cursor to move the jacket around. Hold the Shift button to make the grip softer, less aggressive. And if you like what you see, save your garment again. Alright, so now I want to bring this cool t-shirt into our Unreal project. As you can see, we've already got some other clothes in here like these jeans and the jean jacket, but we can only bring in one piece at a time. So, we got to hide the other clothes for now. Next up, we want to bake the textures, which means we got to make sure the UV map has no overlapping, and all the exported parts fit into the first quadrant. I see some overlapping here, let me fix it real quick. Got it. Additionally, before we import the t-shirt, we may want to check the particle distance. Let's keep it as 20 mm since it'll be underneath the jacket and won't be moving much. To maintain good performance, it is also advisable to avoid having too many vertices when they are not necessary. Now, let's hop back to Unreal Editor and import that t-shirt. Don't forget to bake the textures. We can finally bring the jacket back. Finally, the simulation can be run, and if everything looks good, both garments can be saved. Alright, time to get these cargo pants ready. We're going to simplify the design to remove unnecessary elements that will either be hidden or might cause problems during the simulation. First off, we can get rid of these knee patches that make double layers since they won't show anyway. And these internal parts for the pockets, they're going to be hidden, so let's deactivate those too. Same goes for these belt loops, they won't even show under the shirt and jacket, plus they might cause problems. So let's get rid of them. Next up, we'll create a new material slot for the waistband and assign the waistband pattern to it. Let's set up some reasonable particle distance for these pants. When we set the particle distance, we should remember that higher distance makes the fabric more rigid but also helps the performance. So let's set it to 16. And for the mesh type, we can choose either triangle or quad, but let's not use the ramesh option. For this experiment, let's sew the fly's parts together and remove the zipper. We don't import zippers, and the fly will be hidden under the t-shirt anyways. By the way, ChatGPT told us a joke. Why did the pants refuse to go into the fitting room? Because they had a zipper problem and didn't want to get caught with their fly down. Now let's check the top stitches. We'll go with the default top stitch, but make sure the stitch type is set to texture. Before importing the pants into Unreal, we want to make sure the pockets are layer 1. And the flaps are layer 2. And just in case, let's create another material for the flaps so we can tweak them in Unreal if we need to. Finally, we got to make sure that we've got no overlapping in UV map and all the exported parts fit into the first quadrant. Let's get back to our Unreal scene. For now, we're going to turn off the jacket and t-shirt. Then, let's import our cargo pants instead of these jeans. We select compress to make the textures DDS format and hit bake so we can see the stitches. Next, we'll tweak the material properties. I'm going to make these pants more rigid by upping the bending stiffness. We'll also bind the waistband, so the pants stay up. If you need help with binding, check out our tutorial in the video description. Now, onto the pockets. Let's make them thicker. Hit play this level to start the simulation. Looks like we need to adjust the flap material too. Let's make it a bit thicker and increase the bias. That's good enough for now. We can darken the fabric a bit by adjusting the pattern settings. If we want, we can also adjust the normal strength. Now that the pants are looking good, we can bring back the t-shirt and jacket. Just make sure they're in the right order in the Draper editor list. Pants at layer 0. T-shirt at layer 1. And jacket at layer 2. Hit play to see how they all look together. If everything is fine, we can save our garments. Before we animate our character, you may want to adjust the binding settings to avoid clothes falling off or tearing while moving. You can check out our binding tutorial in the description below. Now, let's try animating without using binding. Here we have an animation sequence we want to record. We start by playing the current level first and wait a few seconds until the cloth simulation starts before starting the animation. As we can see, the jacket slides off the shoulders when the character makes a quick turn. We can try increasing the jacket's friction, but it's safer to apply bindings to our clothes. We won't go into detail about how bindings work in this video. You can watch our tutorial video for that, which we made not too long ago. Bear in mind that this isn't an exact science, so you can experiment with your own binding settings based on your clothes materials and your target animation. Now that we've set all the bindings, let's play the animation. It looks better now. Now that we're satisfied with the binding settings, we can create a simulation cache to render our animation in higher quality. If you want to learn how to do this, check out our detailed tutorial about the simulation cache in the description to this video. Here, we quickly add tracks for our clothes and create event trigger tracks for each garment. Then, we add events for each garment and bind them to the cache function. We also specify a folder name to store the cache data. In this case, the cache files will be stored in each garment's subfolder. To cache the simulation, we need to render the video for our animation using either a legacy renderer or the movie render queue. Let's cache our animation. And finally, we might want to check the output folders to make sure the cache files are stored correctly. So, now that we've got our simulation cache all set, we can render our animation in a more complex scene with a bunch of light sources and cool visual effects. In this scene, we've got our metahuman character wearing all the clothes we prepped earlier. Since we already have the cache, this time we need to turn off the simulation for each piece of clothing. In the sequencer, we have the same animation and garment tracks with the cache events. But this time, the cache will play back because we turned off the simulation for our clothes. To render our video, we open up the movie render queue. Now that we have the simulation cache, we can override the anti-aliasing settings. There are a couple of scenarios here. If you're not using motion blur, i.e., it's set to 0, we recommend using spatial samples while keeping the temporal sample count at 1. If you want to use a higher temporal sample count, you'll need to set the motion blur to 0.1 or higher. These options should work fine with the anti-aliasing override. Otherwise, you might have some sync problems when rendering clothes. Finally, we hit the Render Local button to start rendering. Just keep in mind that remote rendering isn't supported. As we can see, everything's syncing up nicely, and here's the final video.
Welcome to the machine, my friends, where algorithms rule and the game never ends. A world of wires, gears, and cogs in between, where they program you to fit the routine.